Okay, section 2.6 is on finding the domain of a function when you're looking at its equation and also working with combinations of different functions. So recall what the domain of a function refers to. Domain are all your inputs or all of your independent values. Usually those are your x's. There's two main things that you have to watch out for when you're looking for domain. Two main restrictions that you need to be aware of. Make sure you write these down. First is that you cannot have a 0 in a denominator. So remember, you can never divide by 0. So any number that would make a denominator a 0, you would leave out of your domain. And the second criteria is that you can't have a negative under a square root. Remember, we can't take the square root of negative numbers using real numbers. We did it back a while ago with imaginary numbers, but we're only talking about real numbers with these when we do a domain question. So we can't take the square root of a negative number, so we have to deal with that if we have a square root. So let's take a look at this example. It just asks us to find the domain of the function. We don't have a graph of this, so it's hard to do without looking at a graph, but if you remember those two things we just talked about, can't have 0 in the denominator, can't have a negative under a square root, then that's really all we need to know. So ask yourself, does the function have a denominator? And the answer is no, it does not. Does the function have a radical or square root? No, it does not. So if neither of those things are involved, then it's very simple. Your domain is just going to be all real numbers. So remember, an interval notation, that'd be from negative infinity to infinity. Here's a picture of it. This would be a parabola, and you can see it would just keep going in both directions, no breaks or anything like that in the graph. Okay, how about this question? They asked us to find the domain of this function. So this time, hopefully you notice that we have a denominator, right? So what we need to do is we need to figure out what values of x would make the denominator equal to 0. So the way we're going to do this is we're going to set the denominator equal to 0, and we're going to solve that equation. So this is a quadratic equation. Remember, with quadratic equations, three terms like this we can solve by factoring. And then if I set both of those expressions equal to 0, the two numbers that would make this denominator 0 are -1 and 3. So I'm going to exclude those numbers from my domain. So my domain is all real numbers except for -1 and -3. Take a look at this interval notation and make sure this makes sense to you. So I want everything on the number line from -infinity up to -1, but I don't want to include it, so I'm going to use a parentheses. And then union, I want to pick up on the other side of the -1, so parentheses -1 up to every number until we get to 3. We don't want to include 3, so we're going to put a parentheses around that. And then we're going to pick up on the other side of 3 and go from 3 parentheses all the way up to positive infinity. So this tells the reader you're using every number on the number line for your domain except for the -1 and 3, because we use parentheses to designate we want to exclude those from the domain. How about this question? Find the domain of this function. We don't have a denominator, but we do have a square root or a radical. So remember we said we can't have a negative under a radical. So the way we're going to handle this, when you have a radical, you're going to take what's under the radical, whatever the expression is, and you're going to make it greater than or equal to 0. So take a look. I took 3x plus 12 because it's under the radical. I need that to be non-negative, so I'm going to make an inequality and make it greater than or equal to 0. Then we're going to solve that inequality. Just like we solved inequalities at the end of chapter 1. And then let's write this in interval notation. So we want all the numbers from -4 up to infinity. And this time we want to include the -4 because it's greater than or equal to, so I put a bracket around -4. Okay, let's take a look at combinations of functions. So make sure you write these definitions down. I'm going to label my functions. I'm going to call them f and g, but they could be called anything, but I'm going to use f and g to demonstrate. The sum of two functions, the notation for it would be f plus g of x, and that would just mean taking f of x and adding it to g of x and combining any like terms that you may have. The difference of the function would be f minus g of x, so that means you're going to take f of x minus g of x. Make sure you distribute the negative. The product, f times g, we would just write fg Sometimes there's a little dot in between them, or they just might be next to each other. Fg of x, that means we're going to take f of x and multiply it by g of x. And then lastly is the quotient, f divided by g. So we're going to take, literally the notation is f over g of x. So you're going to take f of x and divide it by g of x. Okay, so the question says let f of x equal the function 2x plus 1. Let g of x equal the function x squared minus 2. They want you to find all four combinations, the sum, the difference, the product, and the quotient. So make sure you're writing these on your paper. Try to work along with me. Let's start with f plus g. So that's going to be 2x plus 1 plus x squared minus 2. Combine like terms and simplify it. We get x squared plus 2x minus 1. The difference, f minus g, is 2x plus 1 minus x squared minus 2. Notice I put parentheses around that. That negative has to be distributed. Don't forget that. So when we combine like terms, we get negative x squared plus 2x plus 3. F times g, so we're going to multiply 2x plus 1 times x squared minus 2, so we can FOIL that. And then last, f divided by g, we're just going to take 2x plus 1 and put it over x squared minus 2. That's it. Don't do anything else with it. Don't try to actually divide. We'll do that in the next chapter. For now, just put f over g, and that's all you have to do. Okay, the next question asks us to find f plus g of x, and then asks us also to find the domain of f plus g. So the functions they gave us are f of x equals square root of x plus 3, and g of x equals square root of x minus 2. So to add, we're just going to literally add those two together. So we have the square root of x plus 3 plus square root of x minus 2. Now remember, with radicals, you can only add and subtract when they are like terms. These clearly are not like terms. We have an x plus 3 under one radical and an x minus 2 under the other radical. Cannot do any more simplification. That's it. Now let's talk about the domain. So for the domain, we're going to look at the domain for f, and we're going to look at the domain for g individually. So start with the domain for f. The function was the square root of x plus 3. We have a radical, so that means we need to take the x plus 3 and make it greater than or equal to 0. And then when we solve that inequality, we get negative 3 to infinity for the domain. Go ahead and find the domain of g of x. Take a minute and pause the video if you need to. You're going to take the x minus 2 and make it greater than or equal to 0. When you solve that inequality, you get 2 to infinity. Now, for the domain of the sum, the combination, you're going to look at where these overlap. So think about if you were to draw this on a number line. We have from negative 3 to infinity and 2 to infinity. Which one of these is more restrictive, covers fewer values, or a smaller part of the number line? That would be from 2 to infinity. So that's going to be the domain. We won't get into domain a whole lot with combinations, but we will. I just want to make sure you remember how to find domain for each function on its own. So if I just said f of x or g of x, find the domain for each of those. That's what you want to make sure you know how to do. The next thing in this section that we need to follow is composition of two functions. So this is a very important skill. If you do go on to pre-calculus at some point or calculus, you're going to need to be really comfortable with composing two functions together. The notation for it is a circle. So this is read f composition g. It looks like fog. It's not really what it is, not an O. It's f composition g. And you can do the other one. Oh, let me give you the notation for it. F composition g of x. So when you see this notation, it really means this. This means you're going to take g of x and you're going to substitute it into the f of x function. We'll do some examples. And we can go in the other direction and do g composition f. The notation for it looks like this. So g composition f means you're going to do g of f of x. So wherever you have an x in the g function, we're going to replace it with f of x. You want to think about whenever you do these, which is your outer function and which is your inner function. So we have an inside function. We're going to substitute inside of another function. So let's look at an example. So say we have the function f of x equals 3x minus 4 and g of x equals x squared plus 6. So first they want us to find f composition g. So which is the outer function and which is the inner function? So the one that's written first is going to be the outer function, and the one that's written second is the inner function. So what I do with these is I say, okay, if it's f composition g, f is the outer function. So I take whatever that outer function is, in this case 3x minus 4, and on my paper I write wherever there's an x, I replace it with parentheses. So I've got 3 parentheses minus 4. That's all I do. Think of that as like your outer shell with the outer function. And then inside the parentheses is going to go the inner function, which is x squared plus 6. That's your composition. And then simplify it if you can simplify it. Combine like terms, and there you go. Let's go the other way. Same functions, but this time they want us to do g composition f. So this time, which is the outer function? G is the outer function because it's written first. So take your outer function. Wherever there's an x on your paper, I want you to replace it with a parentheses. So we're going to have parentheses squared plus 6. Now what's going to go inside of the parentheses? That's the inner function, which is now f, or 3x minus 4. We're going to square this, of course. Make sure you remember we have to FOIL. Please don't tell me that's 9x squared plus 16. Make sure you FOIL that. When you do, you get 9x squared minus 24x plus 16 plus the 6 at the end, and combine like terms. Last thing for these same two functions we're working with, they want us to do f composition f. So same idea. F is my outer function because it's listed first. It also happens to be the inner function. So I've got 3 parentheses minus 4. What's going to go in the parentheses? Happens to be f again, so that's 3x minus 4. Simplify that, we get 9x minus 12 minus 4, which is 9x minus 16. Last but not least, they want g composition f of 5. So this time we're not going to have an f in our, a 5. Let me try that again. We're not going to have an x in our answer. We're going to have a number because they want us to replace x with a 5 at the very end. So since we're working with the same two functions, I'm going to go back to what I wrote a few minutes ago. Look back in your notes. G composition f of x was this expression, 9x squared minus 24x plus 22. So once you've done that, now we're going to replace all the x's with a 5. And then follow order of operations, of course, exponents first, then multiplication, and when you simplify it, you should get 127.